Now, one of the things that we're really interested in when it comes to dealing with trigonometric functions is, of course, angles and standard position. And from here on out, just about every reference we make to an angle will be to a standard position. So the initial side is always measured along a positive x-axis. And let's go to degree measure, because that's what I think most people are fairly familiar with. Degree measure, we've been pretty much brought up with it. If we say something like, I have an acute angle, it means that the angle is less than 90 degrees, right? An angle that's less than 90 degrees. Well, we should be more specific because we could have negative and positive angles. So we should say that if we have an angle, I'm going to introduce a symbol, the Greek symbol theta, to represent my angles here in standard position. So theta being my angle in standard position. If it is acute angle, it's between 0 degrees and 90 degrees. If it's an obtuse angle will be an angle that is between 90 degrees and 180 degrees. Let me get that straight now. 180 degrees. Okay. So acute versus obtuse angles, of course, we know that our right angle is the 90-degree angle. We've pretty much had that bored right into our memories from years and years of school. So a right angle would be exactly 90 degrees. And of course, a straight angle, if you've never heard of it, the word straight angle is 180 degrees, right? So we'd call that a straight angle because it's an angle that looks like a straight line. Well, in standard position, of course, we know that we can refer to certain positions, key positions along that circle, starting with 0 degrees, being right at the start of our rotation. If I rotate in the positive direction, I'm rotating in the counterclockwise direction for my angle. Counterclockwise, clockwise, there we go, W. Counterclockwise means that I'm going in the positive angle position, so 0 goes to 90 degrees, positive 90 degrees in the counterclockwise direction, positive 180 degrees, and continuing positive 270 degrees, all the way up to 360 degrees being one full rotation. Now we can actually have more than one full rotation. For example, if I told you I had a rotation of 720 degrees, that should tell you that is 2 times 360 degrees. So I have an angle that is going to be coterminal with 360 degrees. In other words, we can have greater than one full rotation. This is 2 full rotations. 2 full rotations. Right, this is 1 full rotation, okay? So we can say that our angle measured in standard position, acute versus obtuse, straight, right, coterminal angles, right, positive angles. Negative angles would be in the clockwise direction, by the way. So if I had a negative angle, like this angle looks to be approximately negative 70 degrees, for instance, negative 70 degrees would be an angle measured in standard position by coming down from the x-axis 70 degrees in the clockwise direction, and I would say negative 70 degrees would be right about here. All right, so an interesting question comes up. We have a definition of something called a coterminal angle. Two angles that are said to be coterminal if they have the same terminal side in standard position. So let's think about how we could come to this kind of conclusion. How could we get a coterminal angle, one positive and one negative, for this standard position angle? Well, a coterminal angle might be found by, for example, adding 360 degrees or subtracting 360 degrees. So if you think about 210 degrees, if I added 360 degrees, I went around one full rotation to come back to the same terminal position. The angle 470 degrees is an example of a coterminal positive angle to 210 degrees. If I were to draw that out, I would think to myself, well, 210 degrees is right here, and I'll put this in black. You have a 210 degrees, a little bit greater than 180 degrees. See it, right? If it's between 180 and 270, you're in the third quadrant. So we're in the third quadrant right here. So we think, all right, let's go 360 degrees more than that. So if I had an angle that was 360 degrees more than that, I'd reach 210, then I'd go 360 degrees more, and here is the picture of my angle 470 degrees in the positive direction. Well, let's go the opposite direction. What if we went to the negative? Well, 210, take away 360 degrees. Well, we can work that one out too, right? If we take away the zeros, 5 and a 1 right here, negative 150 degrees would be the equivalent to that. Negative 150 degrees means starting in standard position, rotating in the clockwise direction to get to the same position as positive 210 degrees. Not too bad. How about this negative 145? Well, if I'm given an angle that's already in negative position, we want to figure out, well, what should our coterminal angle be? Well, let's find one that is positive. So a positive coterminal angle could be found by adding 360 degrees right here. Adding 360 degrees means that we take a 10, take away 5. This would be a 5, take away 4. That would be 5, right? And then a 1. Let's see, from 3, that would be 2. 255 degrees. 255 degrees? No, I don't believe that. Going back to my calculator, it's positive 215 degrees this time. Positive 215 degrees. Kind of similar to my last situation, only the last situation I was given a positive angle. Here, I'm given negative 145 degrees, right? That's my given angle. So if I want to find my coterminal angle, I could go in the positive directions, one rotation, right? If I add 360 degrees, I get 215 degrees. Here it is, 215 degrees. And then, of course, if I take my angle, negative 145, and I subtract 360 degrees, I could get another coterminal angle, this time a negative. This time a negative. So minus 360 more degrees. Let's see where that puts us. Well, negative 145, negative 160, that's a 5. It's a 10. Bring up the 1, 5. Negative 505 degrees. And if I were looking at negative 505 degrees in my diagram, I would think to myself, well, negative 505 degrees means that I rotate clockwise another full rotation away, and that puts me at negative 505 degrees. So these are how I get coterminal angles.